third year where we're having this conference. Unfortunately, one of them was skipped, so it's not consecutive years, but 3 years, third conference that we are organizing here in the IEEE department at Imperial. I'd like to start by introducing our student branch and what we do and the sort of events we organize. So the aim that we have as a student branch is to offer unique environment for postgraduate students to join ICL-focused research developments or other university developments or industry developments, to network with people from industry or other universities, including our university as well, and social activities. We also organize workshops, conferences like the one today, and social events here on campus. Our IEEE student branch brings you, the students, the opportunity to interact with industry for research and even potential recruitment. Some of the recent events and achievements that us as a student branch have managed to gain this year, we have had the Women in STEM roundtable discussion around March time, when we usually have this annual event as well. And you can have a look at our conversation using the QR link on here. We also have been awarded for the best student paper in the student contest 2022 edition. And we have also inaugurated our own power and energy student chapter here at Imperial. For more details on our events and our activities, you can find us on our website, as it's written down there, and you'll have the chance to get that website later on as well. Now to introduce our committee members, we have quite a big team this year, which is a fantastic achievement of our student branch. We have the chair who couldn't be with us here today, but I'm going to introduce him because he's the mastermind behind all the events this year. That is Stefan Borzan. We have the vice chair and treasurer, Emily, the secretary, Sadia. We have industry liaison, Hakan, communications officer, Malik, and some other committee members that have more recently joined our group, Amir, Pavan, and Malak. And we also have an MSc representative to not forget about our master students, Miao. I'm part of the advisory committee, and I'm very happy to be here today to welcome you to this conference. And also we have Dr. Faris, also part of the advisory committee, and our academic advisor, Dr. Christos Papavasiliou. I'd also like to thank today for helping us organize this and putting all this event together to our PhD representatives here in IEEE building, and that is Cedric, Dimitra, Jamima, Joseph, and Young, and also the Department of Electrical and Electronic Engineering for supporting our student branch and allowing us to have these events in campus. Today's program, we have already been through registration and coffee. If you haven't had a chance to take a coffee and tea, you'll get a chance to get them there at the back of the room. This is the conference welcome, if it's not clear. And next we will have our keynote presentation and a Q&A session, followed by our lunch break. We will be providing lunch, and our IEEE local student paper contest hopefully will be the winners this year as well. And then we have our PhD research presentation, and we'll conclude our conference with some refreshments. To start our conference, I would like to introduce Dr. Muhannad Alomari. He's the head of AI across Europe for Artifactory at Rolls-Royce, and he's working on solving some of the most challenging engineering problems through the application of AI. He's also a honorary fellow at the Neuroscience Department at Imperial College London, at the Computer Science Department at City University of London. And he speaks 2 human languages and 7 computer languages, and it's an advocate for using AI for the good of humanity. Now, please join me in inviting our guest here for his speak, and I'm not going to talk any longer because I'm sure his talk is going to be much more interesting than my welcome. Thank you very much.
Thank you. Right, hopefully you can all hear, see me online. And hi everyone, nice meeting you. I am Dr Muhannad Alomari. And yeah, as Alina just said, I'm the head of AI at Osquad Factory. Really nice being here, and thank you for inviting me. This is always great to come and talk to like-minded people. So I'm really excited about this. Right. So today I will be talking about AI. I can see that I'm out of. Yeah, fine. Okay, so I will be telling you a little bit about the AI activities that we are currently running in Rolls-Royce and how basically we've managed to successfully deploy AI in some mission critical applications to actually derive some value from AI and some successes and failures and ultimately lessons learned in this space. Right, maybe just a brief introduction about Rolls-Royce, just in case that's not really very common, should be, but just in case. So we're not the car company, we are the power system company, so we don't make cars. That was my first question, which is not a good question to ask in an interview. And so Rolls-Royce have 5 business units. For example, we make airplane engines that the civil aviation industry, we make nuclear reactors that the civil nuclear industry, etc. So we have 5 business units within Rolls-Royce. They all make different products related to power or generation of power. And basically my team, which is the R² factory team, sit at the central technologies. So we sit at the heart of Rolls-Royce. So we don't belong to any of the business units within the company, but our job is to help advise and basically develop capabilities for all of these units, which is really exciting, by the way, because I get to play with some really cool stuff. Right. So I want to talk about 4 things today, and it will be quick, I promise you that. So the first one is going to be about COVID-19 and the impact it had on Rolls-Royce. Second, I want to talk about AI use cases to derive value, so cost savings, etc., efficiencies. And then I want to talk about AI for good, because I believe everyone in here, has the responsibility, and I'm sure if everyone given the opportunity to develop or use their skill set for the good of humanity, you will all basically be jumping on that. So I want to talk about my own personal experience and how we've managed to deploy AI to help someone's life, basically. And then lastly, just a single slide on lessons learned in this journey that I had with Rolls-Royce. So to start with, COVID-19. So I want to start by talking about the state of the civil aviation industry during the pandemic. So basically how we were doing at the time, and I'm sure you all remember that, it was not lovely. But basically for the civil aviation industry, it was specifically not lovely, as it was particularly bad. So what we're looking at in here, this is the dashboard or the data provided by the International Civil Aviation Organization, the ICAO, showing the differences in number of flights between 2019 and 2020 globally. So if you look at this figure, you will see that in January, for example, there was about 3.5 million flights worldwide, which increased to about 3.8 flights, in January 2020. And as we started hearing about COVID, everybody started sort of panicking-ish. You start to see, February was fine, March was bad. We've lost like 1 million flights, etc. But by the time we get into lockdowns, it was proper bad, as in we've lost so many flights during that time. And that basically, if I were to quantify that, in May that year, there was a cancellation of nearly 3 million flights worldwide, which is not a small number, especially considering that the way the civil aviation industry works, the engines are actually extremely expensive to build and manufacture. So they sell them at a loss. This is almost universally true for all engine manufacturers and even airframe builders. So they sell them at a loss, and then they make their money by licensing them, as in by basically having these long-term contracts, which is called fly by the hour. So the more the engine flies, the more money we make. As the engines were not flying, not good. So overall, globally, it's estimated that in 2020 alone, the industry, which is the civil aviation industry, lost close to $372 billion, which is, an astronomical number, really. What that meant for Rolls-Royce specifically, just to give you a rough idea, in 2019, Rolls-Royce made about 16 billion pounds in revenue, more than half of which, actually 52% of that, came just from the civil aviation or the civil aerospace unit. So basically, that revenue is pretty much slashed because no one was flying, and it was, again, particularly bad. So the story that I'm telling here is that COVID happened. Of course, nobody predicted it, but it was really quick to move from an industry that was making about 16 billion pounds a year to one that half of that is basically, under lots of scrutiny or not even existent, right? So it was huge impact for us in the company, and everyone was mobilized. Basically, every single team was put in action to try and help reduce the impact so that we can help Rolls-Royce survive that period, which takes me to my next point. So how did we use AI to help derive value for the company? And I've been having lots of discussions with Amber just before this, but AI, there's a lot of hype, there's a lot of cool demos out there, But the key thing that I want to emphasize in here is that there is a way where you can actually use AI as a useful tool to get value out of it, which is really the core of what we do in the AI team in Rolls-Royce. Right, so the impact on Rolls-Royce civil aerospace supply chain. So I want to focus specifically on this unit, although there was a large number of activities going, but this one is actually one of the ones that I particularly like. So very briefly, the civil aerospace supply chain unit. It's pretty standard in terms of how we structure our supply chain. So in engineering or in civil aerospace specifically, there are generally 3 tiers, they're called, and how we manufacture components. It all starts with the melters. We call them the melters. Basically, these are the companies that dig metal out of the ground to make the alloys. That alloy is shaped into billets and then shipped to forgers, which basically make them into rough shapes. For example, like you see in here in a ring, that ring is then shipped from the forger to the machinist. When at the end, they have insanely accurate machines. We're talking micrometer accuracy that will ultimately basically machine the forging into a component, and that ends up on an engine. So pretty straightforward. Right, so it's complicated, just like a spoiler alert. So it's not as easy. So unfortunately, the reason why it's not as easy as basically that 3 tiers is because for a lot of good reasons, we have some mitigation strategies to avoid being, falling into some problem while we are manufacturing components. One of these strategies is something that we call dual sourcing. And dual sourcing very briefly means for any one components in any one engine program, we have at least 2 suppliers that are capable or actually contracted to manufacture that component. So say for engine 1, we have component A, we have 70% of the demand produced by machinist 1 and 30% by machinist 2, which is like a typical way we structure our sourcing strategy. And that sourcing strategy is reflected across the entire supply chain. So for that component, for each machinist, we instruct that machinist to go and buy the forgings from 2 forgers. And then for every forger, typically what we do is we ask that forger to buy the billets from 2 melters, etc. So you see that, for every one component, you have this sort of expanding network of how we are doing this. So far, so good. The challenge becomes is that the same component on one engine program is actually used across engine programs. So engine 1, engine 2, there's a Trent 500 blade, the fan blade downstairs that we just had a look at. So for example, some of these, like the nose, for example, is actually used across engine programs. And therefore, the same component have 2 different teams, again, for lots of good reasons. This is not just because we like to complicate stuff. There are 2 different teams that are sourcing that component, which means that component, instead of going like 70-30, in engine 2, they decided, again, for whatever reasons, they're going to go 100% with machinist 2. And then they decided, because they have better relations with forger 1, to instruct machinist 2 to buy 70% of whatever these guys ask from a second forger. What happens typically, so this is sort of the design, but what happens in reality is that machinist 1 quickly realizes, actually, this is cheaper. So I'm just going to buy all my forgings from here. I'm just going to ignore whatever I'm told, and I'm going to do whatever I want. I'm just going to buy all my forgings from this forger, because then I will make more money. And to add more complexity, the same component is actually governed across business units. So not only between engine programs, but the defense engines that we build, there are components that are shared between the civilian engines and the defense engines, which means we have completely different teams that are making the same component in so many different ways. And that is just one component. But if you look at the wider picture, and this is the challenge that we were presented with, we have more than 5,000 vendors across 60 countries, making more than 50,000 unique line items. And basically in 2020, the planned spend we had was about £3.5 billion. So it's not a small operation. And the thing that COVID did was it basically highlighted all the issues that we had in our civil aerospace supply chain in terms of how we were managing that entire operation. And I'll dive into that in a second. But basically the 2 questions that we were asked is, can I cancel this order? So clearly the story is, lots of airlines are no longer going to buy engines, so we have to make less engines. And therefore, the first questions that we asked, and we had literally millions of order items, is can I cancel any of these? And if so, which ones? And the second question that we were asked by the defense business, because as the civil aviation industry was sort of not doing too well, the defense business was actually as busy as it gets, because they were flying military engines across the globe, basically carrying supplies, basically evacuating civilians, etc. So they had the opposite problem. Is they were saying, right, if this supplier goes offline, can you tell me the impact on my engine? And it's a nightmare question to ask because there is everything that we planned, which is not easy, and there's what's actually happening in reality because suppliers change, whatever. So the question that we would ask then is, right, just spend a month, do whatever, but get me some answers. As in, come back with actual answers to these very difficult questions. Right. And again, just to emphasize the size of the operation, as I said, 3.5 billion, 50,000 unique items, 7,000 different alloys, 5,000 vendors, 60 countries. We actually employ more. We actually employ more than 500 employees, and their day-to-day job in Rolls-Royce just to ensure that components keep coming. So just that's like their daily life is just making sure that components keep coming. And just to give you a size of scale, to order a blade, it actually takes 2 to 3 years lead time to get the blade because you have to source the metal, which is the rare earth metals they're called. They're very rare, and they're not easy to get by. So you spend up years planning what you want to order in advance. So it's not as phone someone, get a component. So it's a really large operation. We have 12 different data sources in terms of how we manage this. And as you would imagine, if you look at any one source, there are lots of gaps, lots of missing information, lots of inaccurate information. If you look across sources, there are conflicting information. So one says, one source says something, the other says another. So which one do you trust? So we had a massive trust issue in terms of, depending on which database you're asking, you get completely different answers. And that's the challenge that I want to talk about next. Anyway, lots of stuff, but just what's interesting, which I learned there, is that we buy 20,000 tons of high value alloys, which is actually enough to build 2 Eiffel Towers every year of these which I think we should just do one, right? As in that just sounds, why not? Right, so the first challenge, digitization. So as I was saying about the 12 data sources that we were looking at, basically, simply, we couldn't really rely on any one of them to do our job. So we had to go to the source of the data, which being the contracts, the engineering drawings, or the different documentation, which is presented in a PDF or a paper format even. And we had to find a quick way to digitize all of these to extract the information so we can answer the questions. Sounds pretty straightforward. So in one activity, we're looking at about £1.6 billion spent and lots of different documents. Just to give you an example of the nature of the documents, this is an actual page from one of the contracts, which had a table. It's called the schedule table. And engineers love tables. I'm just going to say that will make sense a lot in a second. But basically, tables are a nightmare to digitize because telling the difference or teaching a machine the difference between a line that is part of the table and another line, which looks very similar, which is part of a character, is not easy. As in, why is this P and this thing is like not a whatever character? Like, why is this not an L? It's actually very difficult to digitize tables. And the question that we're asking particularly, and maybe it's interesting, maybe it's not, but there are 2 zones defined in the contract called the firm zone and the trade-off zone. Without too much detail, basically these govern the legalities of whether you're allowed to cancel an order or not. So there are periods of time to say, if like a month before you receive the order, you're legally liable or binding to buy that component. You just can't cancel it. So this is the question, and literally it's different for every single component, for every single supplier, for every single period of time. So it's not easy. Right. So we tried everything as a starting point. So every single algorithm that they're called OCR, or optical character recognition. They're a type of computer vision area where they look at basically digitizing written text. And we looked at every single, this is 2020, just to highlight that. Not a single source for doing OCR that we tested was actually even remotely good enough to the kind of task that we had in mind. There was clear separation between what exists in research or even in companies such as cloud, massive giants, tech giants, in terms of what they are developing and what the industry actually is needing. And so we had to develop our own engine, like it's an OCR engine, very quickly to digitize tabulated data, which makes sense because if you look at an engineering drawing, it's basically a massive, one table with a massive cell in the center, which contains the design. So still is a table. Worth highlighting that this was built based on classical computer vision, so not deep learning, not any other fancy technologies, which I will get to that point about the end, because the point of what we do is that we want to realize the value as quickly as possible. It's not about AI. AI is a means to end, or basically one of the tools that we have. And the quickest way we can realize value is the way forward for us. So anyway, we've developed the system, and basically, hooray, we actually did digitize like a few 100,000-ish documents. And what that meant is that we were able to extract more than 1 million data points out of all of these, which basically formed the single source of truth in Rolls-Royce for all the data that we had in our civil aerospace supply chain. And it resulted in us saving more than £500 million in 2020 alone in cash flow, because we were able to cancel orders fairly quickly without falling into that legal period, which basically says no longer we are allowed to cancel that. So that was a big success for AI. And this is one of the examples. Worth saying that there is this thing called REACH, which companies have to, it's a European regulation for chemical substances, which sort of makes sense. If you're taking anything into Europe, you have to declare what chemicals went into the making of that thing. And there are certain chemicals which are simply not allowed into Europe. Again, makes sense. Again, it's actually really hard to comply with this, because looking at all the different tiers, all the different processes in all the suppliers, which are very different, and tracking what chemicals went into the making of any one component is a nightmare of a task to try and do. But because we had all the information, we just by default were able to, for the very first time, actually, be compliant with the REACH regulation. Right. So that was the story about the digitization, which is one of the areas that I want to talk about. And I will be quicker now. The second one is called resource allocation. So because we had all that data sitting there, we, for the very first time, we were able to leverage other AI algorithms to actually help save even more cash, or basically improve the efficiency of our supply chain. And one way to do that is basically by automating, or optimizing, more like it, optimizing the way we give tasks for suppliers. So as I said, we have 5,000 suppliers. A lot of them can make any one component. So which supplier do you pick? Which is the challenge that the buyer community, they're called, which is the people working in the supply chain, that are constantly facing, right, how do I source this component in the most cost-effective way, minimizing risk, time, etc. So if you own a house, actually, this is a bad example because you're all engineers, and I'm sure you're going to do all of this on your own. But imagine you're not an engineer, and imagine you bought a house, and this house has a number of different things that you need to do, like flooring, whatever. And imagine if you ask for some quotations, and there are 4 suppliers that gave you the following prices to do all of these 4 tasks. And the challenge that you have as a homeowner is, right, how do I source all of these different activities such that I minimize the cost? Which is, very simple, trivial. Now, the case in our case, basically the supplies and components, which is sort of the same story, but we have different cost functions to calculate how much any one of these suppliers will cost us to make any one of these components. If your intuition is telling you go with the cheapest and sort of work your way upward, which makes total sense, I can guarantee you it's almost a certainty that this is not going to be the optimal answer. There's a very good chance this is not the best strategy. So if you do that, that's very intuitive. But unfortunately, it's not the best answer. It's actually, there is a way to calculate the best way you could source these tasks to the suppliers such that you minimize the global cost, like you're finding a global optima as opposed to a local optima. And this whole field in mathematics called resource allocation is something that our CPUs use every single time they try to prioritize whether I should use Teams or look at Microsoft PowerPoint or any of the different applications. So you have a finite amount of resources, being the 4 or 8 cores that you have in your CPU. So this is a very well understood area in mathematics and optimization. And if you're able to formulate whatever research project that you are working on into one of the standardized algorithms that we know very well how to solve, then you can reach the answer very, very quickly. So we've actually done this on a lot of suppliers. We had some research with Cambridge as well working on this. And what's worth saying is that in one conference, we were looking at $1.1 billion worth of spend. And it was for the next 10 years. And by including this optimization as part of the strategy of how we're going to source these components, we actually managed to save more than $180 million out of the planned $1.1 billion. What was interesting is we had shipping distances as part of the cost. So, the longer the distance, the more expensive it is. And by optimizing for cost, it wasn't part of the plan, but we ended up minimizing the shipping distances. So we ended up, if 2 suppliers are near to each other, if one is slightly more expensive, overall it works out cheaper, so just send to that supplier. We actually ended up saving more than 100,000 trees worth of CO2 emissions from that small portfolio of components, which is huge, really nice. That is just in reducing the shipping distances between suppliers. So we saved money, our suppliers were happier, and actually we've actually saved a lot of CO2 in this. So now this is turned into a global activity within Rolls-Royce, where we're revisiting every single sourcing activity that we have and try and optimize for CO2 emissions. So we're giving more weight to shipping distances as opposed to just a cost, which is nice. And this was not one of the things that we were planning for, but it's actually really, really cool. Right, last one, this will be like very quick. Scheduling is a thing that we are just starting to explore. And basically scheduling answers the question of when. So resource allocation answers the question of who. So if you have a number of tasks, who should do the task? That's resource allocation. When should the task be done is a scheduling problem. And again, very well understood problem. We are looking at that because we have issues of components arriving to Rolls-Royce too early and having to sit on a shelf for months, basically occupying that space in our warehouse, which is very basically ineffective. So we're now optimizing not only who does the component, but when should the component arrive so that it's utilized very quickly so that we have more flow across our warehouses, which is a big deal. Right, so that was the end for using AI for deriving value. And hopefully this sort of makes sense. These are just some of the examples where we've actually seen a lot of success in the company in terms of using AI for deriving value. This will be quick, I promise. So it's the AI for good part that I want to talk about. And as in for good for, I'm just going to admit them. Hope that's all right. Oh, somebody did that. Excellent. So this is a project that I started working on about 5 years ago. And basically the story behind it is MND, or motor neuron disease. It's also known as ALS in the US. Is an absolutely horrendous condition. I was actually told by some of the MDs that I work with on this project that it is the disease that medical doctors fear the most because, you know, as in if you pick one condition that you want to be spared from, they would have picked MND. It is that bad. And basically what it is, it's a condition that affects motor neurons, and basically your motor neurons end up fading and then like until they die and you lose control of all of your muscles. Not good. And it affects, it's actually more common than I used to think. So it affects about 3 in every 100,000 people living in the UK. So there are on average about 5,000 people living or battling this condition at any moment in time in the UK alone. So it's unfortunately not as rare as we would have hoped for. And one of the very famous examples of people living with MND and actually thriving people, you know, living with MNDs is the late Professor Stephen Hawking. So he had MND, or motor neuron disease, and he did all the great things that he did. But this gives you an idea of what a person living with MND sort of looks like. Right, so how I got involved in all of this MND business. This here is Professor Peter Scott Morgan. I don't know if you've seen, there was a whole documentary about him on Channel 4. Basically, he was attempting, unfortunately, he passed away literally just a month ago, which is really sad, but he was the first person to attempt to be the first ever human cyborg. So he wanted to undertake a number of surgeries that would allow him to defeat MND or bypass MND, because as your lungs are failing or as your all different bodily functions are failing because you can no longer control your muscles, he actually wanted to bypass that through like a number of clever ways and surgeries. He also happened to be a good friend of one of our colleagues in Rolls-Royce. Unfortunately, that colleague, his dad passed away from MND as well. So he has a family history of like really knowing MND. And when he heard that his friend was diagnosed with MND, he reached out to me saying, right, can we do something as Rolls-Royce? And, you know, through the applications of AI, can we actually figure out a way to help people living with MND? And I absolutely jumped on this because this sounds really cool and I actually wanted to help. And after having a number of chats with Peter here, we quickly realized that if you've ever seen The Big Bang Theory, this is going to make more sense in a second. And if you've seen someone interacting again with the late Professor Stephen Hawking, it's actually very misleading because it takes an MND patient's minutes, like, you know, we're talking 10, 20 minutes to actually draft a single sentence. And I'll explain that better. So just having that conversation with an MND patient, which I have seen firsthand, is actually not possible, right? And the way it goes is basically, if you ask an MND patient, how are you today? The way it currently works is they have this really clever interface, which basically have this arrow that jumps from one row to the other. And basically all the MND patient has to do is to wait for when the arrow is in the right row. And typically, and this is, I don't know why it's fascinating, really, is every single MND patient has this one muscle that they just don't lose control for. So in the case of Professor Stephen Hawking, it was his cheek muscle. So actually on his glasses, there was a proximity sensor placed under his left side of the glass. which basically allowed him to click, use it as a push button every time so that he could navigate or control this dashboard. So anyway, you'll wait like 5 seconds, it jumps to the next row, etc. And then it's here. You press the push button, it goes, and then you press again, and that's one character. So drafting a single word in a sentence can actually take a very long time. However, the clever part of it, which Intel invented, is this sort of clever way of predicting what is the word that you're writing. It exists in everyone's keyboard now, and basically you could accelerate that. But it's really not fast enough. If you're part of a group conversation, and as an M&D patient, you want to say something, it could take forever, right? You'll end up missing on it. So without burdening the point, it's really bad. It developed, basically almost all M&D patients end up developing a form of depression because they can't express themselves well enough. And anyway, it's negative, right? So what we did is, and this was 2017, so we looked at what's available in the natural language processing space. And actually, there is this clever tool that was developed by Google looking at coming up with an automated response for your email on the Gmail app. So they would read the text and they would try and predict whether they can actually give you a response so that you just click on the response and it would answer that. And that sounds clever. That would actually help, significantly better than what the M&D patients had access to at the time. So what we've done is we've designed this tool called Quips. It's open source, all out there. And what Quips does is allows you, instead of seeing that dashboard, it actually listens to the conversation and immediately come up with a number of responses that you can, as an M&D patient, just pick one from. So it helps accelerate that, which was really cool. And it's built on this encoder-decoder architecture, which is actually quite old now. There are like transformers and much better ways of doing this. But again, this is 5 years old. And it did the job. It just worked, right? So some of the things that are like really interesting that we didn't think about while we were doing this was there are actually difficulties or different challenges that we've seen when developing the system. The first one being the quality. So looking at the sentence, it's clearly not good English. So the first thing that typically every NLP engineer looks at is, right, is the sentences formed in a good way? And that is like your top priority. But what we realized is actually there are more interesting aspects to the system than just the quality of the sentences, one of which being the utility of the answers. So as somebody's saying, how are you feeling today? And if you're not feeling particularly jolly that day, and all the answers are like really happy, cheerful answers, you're not going to use it. You're going to end up going back to the older system, right? So the utility of the system meant that we need to reflect as much as we possibly can from the different human emotions. And after reading a little bit, and this is very controversial, I'm sure if there are psychologists in the room, this is definitely not universally true, but there are basically 7 human emotions that governs all of human emotions, which we've used that as a foundation for basically developing 7 different engines, each of which is reflecting a different emotion. And that way, the M&D patient was always presented with the 7 possible answers, and they can pick. And that actually has improved the response significantly with the, after run trial. The last one is the personalization. So one thing they did not like at all, the M&D patients, is when the answers are absolutely dry and this is not me. That is, even though it's faster, but it's not me, and therefore I don't want to say that. So what we've done is we've started learning from their personal messages and any papers or books they have written to try and capture some of their personality type in this example. And this is an actual sentence, like, I'm jolly good, me duck. Apparently they say that in the North, so that's a thing. And so we ended up personalizing the AI based on what people said. And some of the concerns that we've seen on doing this was, once you start touching someone's personal data or personal life, there are so many ethical concerns that you could come up with, right? As in, for example, sentences. Cool, sorry about that. And basically that works. So we actually mined some YouTube videos for more than 10,000 sentences trained in AI, and that will form the foundation of Quips, which was great because it did actually work. These are some of the companies that ended up joining and working with us on this challenge. It became something really massive. And as I said, it actually was featured in a documentary on Channel 4, sort of following the life of Peter Scott Morgan and the work that is being done. After that, this is what the system actually looked like. So when somebody hears, it would just come up with a text sentence and would give you a number of examples. It was actually integrated in a tool that was developed by Smartbox, which is one of the companies that developed these solution interfaces that I mentioned earlier. And the best thing that I've heard, right, was one of the M&D patients describing this as the best Christmas gift ever, because they really like it. They actually did start using it, and it just makes the whole thing worth it. So this is my own personal experience in terms of using AI for good. Is that all? Actually, no. There is a lot more that we can do. And if you want to join, please do let me know, because there's a lot of work that we can do to help these vulnerable peoples, plus many others. One of which is that as the disease progresses, they lose the ability to control a lot, as in the muscles weakens. And apparently one of the more difficult situation is when you lose the ability to control your neck muscles, because the head, and surprisingly to me, was actually extremely heavy, and as an organ, and therefore as you slowly lose the ability to control your muscles, it becomes extremely painful. And the only solution that existed up to, like, very recently, was you wear the same neck collar that you wear if you've been in an accident. So just completely restrict your movement. And it's clearly uncomfortable. It's just not nice. I mean, it's either between being restricted or suffering from this. It's all unpleasant. And we realized there is actually a way to come up with a neck collar design that exactly just compensates for the right amount of muscle loss, that allows you the flexibility to move, but sort of just compensate for that. And the challenge that we faced with this was, it's not because you 3D print this, so they cost nothing, right? It's just the disease progresses so quickly, so that every 1 or 2 weeks, you need another one to compensate even further. And the biggest obstacle or the cost was in the engineering design. So it takes a lot of time for an engineer to design a bespoke one for every M&D patient. So simply not feasible to have an armies of engineers just designing that. So what we've done with UCL was use a concept in AI called generative design, which has been around for ages, right? Whereby you could optimize a component to fulfill certain requirements or constraints, being in this case just compensation for the force. And that meant we actually had a way to very effectively generate color designs, again, in a very cost-effective manner, so that they can be 3D printed, so that they can be used by the M&D patient. This is still, an ongoing activity. And again, it's just going nice. It's all about data. How do you get data for people living with M&D? Again, it's very difficult. Scans are very expensive if you ever had to deal with scans and patient data. But you actually don't have to, because the gaming industry have gone so far in modeling humans and their kinematics and dynamics that we started using gaming engines to actually generate different postures for people with their different ages, weights or BMIs, ethnicities even. And what that meant is that we were able to bypass, again, the data collection aspect by basically generating synthetic data for this activity. Lastly, which is the last thing I want to talk about, is that this activity has actually led to me and a colleague of mine from UCL basically forming our first startups called BioCortex, which is looking at curing M&D as a moonshot, but by basically leveraging something called the microbiome to help cure a lot of diseases, including the M&D, which is the one that we are going after. Happy to chat about that later if you are interested. And the very last thing I want to talk about is some of the things that I have personally learned during this journey of working with Rolls-Royce. And this is not necessarily always true, but it's just something that I live by now, is when somebody says AI, or when somebody says, hey, I have a problem, can you solve it with AI? I think the first question that you should always ask is why? Why AI? Like, why do you want to use AI? And if the answer is because AI is cool, just tell them AI is not cool. That is not the point, right? AI is a tool just like every other algorithm that exists out there. And if there is a quicker, more cost-effective way to get to the value point without using AI, then you really should be doing that. Just using AI for the sake of it is excellent if you're advancing the field of AI. But in industry, where we work, time is everything, right? If you miss the deadline by as much as an hour, that's it. Like it's a 1-0, it's a binary situation. So always ask or question why AI, which is one of the things that I have not, I've learned the hard way, let's just say that. Betting on data is hugely important, because if you are developing whatever system, if there isn't data, it doesn't matter, right? AI is not going to work. So 99% of your time should actually go towards creation of data, like in the activities that we've mentioned. Again, hopefully that gives you some ideas. Start small, because there are so easy to start dreaming big about all the things that you can do if you develop so and so and so, but it's so hard and so time consuming to actually do any one thing. So starting small makes a big difference. And then change is hard, even if it makes absolute perfect sense to do whatever it is you are proposing. Just changing any organization, being like the MND or Rolls-Royce, and I've worked in my capacity with a number of other multinationals, and I can tell you change is absolutely hard, and that is it. So thank you for listening.